In the last episode, I showed you all the tools I use to build custom acoustic modules and studios. In this video, I'm going to walk you through the build process for all of the modules we used in this studio, except the ceiling cloud. That gets its own video coming up soon in the series. We have floor-to-ceiling modules covering the back wall, side walls at primary reflection points, and in the front corners. We'll start with the back wall modules. Note that I also have two other very detailed videos on my channel about the modules we're building for the rear wall. The first video goes through the building process and includes a free downloadable PDF guide with a list of materials, plans with dimensions, a cut list, and a list of the tools you'll need. The second video covers how to wrap them correctly for a super professional look. I've dropped links below, so make sure you check those out too. The first step is to cut all the lumber to dimension on the miter saw. Building an acoustic module is loosely similar to framing a wall. You need studs, you need a top and a bottom plate, and then blocking pieces to hold and compress the Rockwool. Once you have all of your pieces cut, lay them down on a flat surface and prepare them for assembly. Note that lumber will typically have a crown, which is a curved piece on one of the edges. You can identify which is the crown by sighting down the board, and it's a best practice to face all of the crowns up so that your frame fits together properly. Next up, square out your corners with a speed square. And then this is the section where I love to use the brad nailer. If I have somebody to hold the joint together for me, I can just pop in a couple pins real quick, and that holds the joint together while I pre-drill and sink the screws. I typically use 3 screws per joint, and in this case we're just using number 8 Robertson head deck screws. They're nice and cheap. When you're aligning the studs, make sure that you also align them using your speed square pointing up so that you get them on a perfect right angle to the floor. The next step is to add landscape fabric on the back and to staple it in. This contains the Rockwool and prevents any fibers from escaping, and it also just provides a nice back to the module. You never see it, so it's okay to use whatever cheap stuff you can find. If you can, find stuff that is 4 feet wide. It oftentimes comes in either 3 foot or 4 foot dimensions, and if you get stuff that's 4 foot wide, you can just roll it straight on the back of your module and you don't need to cut it. The staplers that we're running are using Arrow T50 staples, which are a really standard type of staple that's pretty much available at any Home Depot. They come in all kinds of different depths, ranging from, I think, 1/4 inch to 9/16. When you're stapling on fabric like this, use the smaller staples. You can either use 1/4 or 3/8 here. If you use deeper staples than that, then if you make a mistake and you need to correct it by popping the staple out with a flathead screwdriver or a butter knife, it makes it a little bit more difficult. And so I just use the thinner staples here. And when we are stapling the fabric on, we typically start from the center of one of the studs or the top or the bottom plate and work our way out. And we put in just a few staples at the beginning, and then we fill in once the fabric is stretched and we know that it's wrinkle-free. When you're done, you should have a staple every 1 to 2 inches. More is probably better than less because, again, you are wanting this to contain the Rockwool bats on the rear of the modules, but you don't need to overdo it. And like I said before, if you make a mistake, you can just use the tip of a butter knife or a flathead screwdriver to pop the staple out, and you should be able to easily just restaple the fabric once your correction is made. All right, so now I want to talk about the materials that we're using for porous absorption, because I haven't talked about this in previous videos. Because in this particular room, one of our main concerns is about base absorption rather than just full broadband absorption, is we've modified the materials that we're using. A lot of people in studios to make absorbers just use one single density of Rockwool. And in this case, we're going to use 2. Now, why is that? So it relies on a concept called graduated density. And when you make a sound wave go through 2 different densities or more, it has a superior effect on the absorption. And in particular, if you use a higher density layer and then a lower density layer, it's going to increase the performance in the bass region. So let's take this concept to the extreme. An actual bass trap has on the front of it typically a membrane or a range limiter, followed by either an airspace that's been damped or just purely by porous absorption. So if you look at a lot of bass traps by like GIK Acoustics or something, they have a 6mm front membrane, and then it's followed by porous absorption. Now, if we are using something that is more dense than the core, it has a similar effect, but it still is going to absorb mids and highs. And so what we're using in the front is the harder, higher density product. This is a product made by Rockwool, and it's called Cavity Rock. And it's 69 kilograms per meter cubed. Now, if you don't have this product where you are, another product by Rockwool that can work really well, it's called Rockboard 40, and it's 60 kilograms per meter cubed. Either one of those will work. And this is actually very similar to Owens Corning OC703, which is a rigid fiberglass insulation that a lot of people use. So if you don't have the Rockwool products in your area, you could use a front layer of OC703, which is 48 kilograms per meter cubed, and it's glass wool, so it's a different fiber structure, followed by a lighter density material like pink fluffy fiberglass. With this material, we're using a 2-inch front facing of the Cavity Rock, followed by 3.5 inches of the more standard Rockwool Comfortbatt. The Comfortbatt is 32 kilograms per meter cubed, so it's less than half as dense as the Cavity Rock. So we have a 2-inch higher density layer, 3.5-inch lower density layer, 5.5 inches of total depth, and that's gonna give us really, really, really good base performance. All right, so at this point, I wanna talk about corners, because these corners are stress points when you wrap it with fabric. So this is the really nice Guilford of Maine anchorage fabric. It's gonna be going over these corners, and you can see these are really rough. There's a lot of chaff and stuff from the miter saw cutting them. And you could come and sand them or round them over with a router, but you're never gonna see this. And so I just prefer to protect the corners with some tape. You can use duct tape, you can use tuck tape, used for taping drywall or taping vapor barrier. You can use masking tape, really, as long as it adheres really well. And you just want tape on the corner, covering all of this stuff. And you can see on the back here as well, I've countersunk all the screws in. This is gonna be the bottom. And so you also wanna make sure your screws are not gonna be scratching your floor. Again, this is gonna be wrapped with fabric, but having some duct tape over those, if you haven't countersunk them in, will be really handy. So yeah, we're just gonna wrap these corners and cover the stress points, and then we're gonna wrap this with our layer of cotton batting and our layer of fabric. Let's go. The next step is to wrap the front of the module, and we do that in 2 layers. The first layer we add in is a cheaper cotton batting layer, and it's usually cotton quilt batting or some inexpensive material that you can add in as a padding layer, and it also adds some opaqueness so that you can't see the frame. If you just add a single layer of the Guilford of Maine fabric, I wouldn't really recommend that. The stress points on the frame can sometimes cause some wear over the long term, even though it's a very durable fabric. And oftentimes I find you can actually see the frame components underneath. So don't cheap out, and definitely put the time and money into adding a base layer on. And yeah, we just used cotton batting here that was cheaply available from Walmart or a lot of local fabric stores. So what you do is you pop the module on, and you cut the fabric to be able to wrap around the back. So if the front face of the module is 4 feet, I usually add an additional foot at least to the wrap, so that it's wrapping the 5.5 inches on either side, so that's 11 inches. So if you give it a foot, you should be able to wrap around the back. But oftentimes it's good to give yourself maybe an inch or 2 of wiggle room if you can. And then it's the same process as the landscape fabric. You're gonna staple in from the center and work your way out. And if you make a mistake, you can just pop the staple out with a butter knife or a flathead screwdriver. The only part that's a little bit difficult about wrapping the front of the module and getting a clean, nice look is doing the corners. And that's something that I covered in depth in the video linked below, which is about wrapping the acoustic modules. So make sure you watch that one, because I give a lot of detail and some tips and best practices in there for getting really, really nice corners. When doing the final layer of Guilford of Maine anchorage fabric, I like to do it inside a nice clean space rather than outside in a garage or a shop or something. And that's especially the case when I'm wrapping it in white fabric. So we're gonna bring it inside the actual studio, and we're gonna finish the wrapping process here. When I'm wrapping the final layer, I also tend to use more closely spaced staples than in the other layers too. This is the final layer that's gonna hold everything together, and in general, you tension the fabric a little bit, not very much. You don't wanna pull on it and cause stress, but you wanna tension it just enough, and it does have some stretch to it, that you're preventing wrinkles from forming. And then I pop staples in at least every inch, usually every half an inch. So I'm using quite a few more staples on the final layer here. Here's an example of the corner wrapping and upholstering and stapling technique. Make sure you watch really carefully and pay close attention and emulate this in your wrapping technique. This will definitely get you the cleanest and most professional looking corners. But again, if you make a mistake, this fabric is extremely durable and it's really, really forgiving. So if you mess something up, you can just pop the staples out and redo it, and you probably won't even see it in your end result. I take a lot of time with my corners because I like them to look really good from all angles. And so I get pretty precious here about the alignment and smoothing everything over really well. You'll notice when I'm pinning in the end of the corner that I use multiple staples in both directions, and that's just to give the fabric a really nice, secure mounting point, because that is a point of stress in the fabric. Also, in case it wasn't abundantly obvious by watching the video, I do the corners last. So I start with putting staples in at the middle of the stud or top plate, and I work my way out, and I leave about 6 inches or so for wrapping and flapping the corner, and that just gives me a lot of material to play with. And if you start with the corners and then work your way in, you can end up with wrinkles in the center of your fabric. So always start from the center of whatever dimension you're working on, work your way out, and then do the corners last, and make sure that when you're popping your staples in out towards the corner, that you leave, I would say, about 6 inches of space on both dimensions so that you have lots of working room to do your corner. Hey, come check this out. We made you a little vocal booth. I just wanted to stop things at this point because I want you to hear the difference that it makes when you actually have treatment on both sides of a room. So now, check this out as we pop up, and my lav mic is now picking up the reflection off the sidewall. So here's how it sounds when we have panels on both sidewalls, and then here's how it sounds when we have a reflective surface on one side. And you can just hear it in my voice. All right, let's get to it. All right, so now we're gonna talk about the air gapping and mounting system for the rear wall modules. I came up with this system. It's pretty rudimentary, easy to implement, and it simultaneously mounts and ensures that there's an air gap on the modules. So this module is 5.5 inches thick, and in general, you don't want it pushing too far into the room. We're already dealing with a very small room. But there's an access issue here where we need to be able to get in and access the light switch. So there needs to be a gap there regardless. And so what we've decided to do is to go with an air gap equal to the depth of the module. So 5.5 inch module, 5.5 inch air gap. Here is the system that I use. It uses a piece of 2x2 that is sized 4 feet to be the same as the top of the module. And we painted it white because it helps it to disappear into the wall a little bit better, so that when you're looking at it, when you're entering the room, it doesn't catch the eye. And so basically what happens is this gets mounted into the studs. So we've measured out, and this wall has studs that are 24 inches on center. And so this long piece allows us to drill directly into the studs wherever they might be using heavy-duty construction screws. And then what happens is this is just a 2x4 offcut. It's been cut to exactly 5.5 inches long, and it sits on top of this piece like this. And the top of the module comes up and just presses right into this in the corner. And then we're gonna use a screw here and a screw in the top of the module, and a zip tie system. I have a whole video on this as well as SketchUp plans. We'll link that below in the description, but that's basically how this is gonna look. Okay, so that's the system. And then at the bottom of the module, to make sure that it can't get kicked in and be at an angle, we're gonna put 2 more of these on the floor. So they just sit at the floor, the bottom edge of the module presses into it as well, and boom, we're good to go, and it's perfectly air gapped and it's nicely secured. So now I want to talk about how to find studs and get going on that stuff, because a lot of you I know may not have any construction experience. So the first thing you're going to want to do is figure out where the studs are. So the studs are in an interior wall, are typically going to be made of 2x4s. They might be made of 2x6s. Typically if a wall is load bearing, it's going to be made of 2x6. But either way, it's going to be 1.5 inches wide. Okay, that's the 2x lumber dimension. You can use a stud finder. A lot of them are pretty good, but they're definitely not infallible. And so we kind of go across and we're going to find where we think the stud finder thinks the stud is, right? So it thinks it's there. And then I just make a mark where it thinks the stud is. And then what I do is I put a very small, thin bit on the drill, and safety glasses, always. And then I just do a little test hole. So you can see I've already drilled this here. And you can feel resistance against the bit. It means you've hit the stud, which is good. If it just punches right in really easily, it means you're just going through drywall, okay? And it means you're a little bit off. So the stud finder will typically find the stud, but you don't know if you're on an edge, on the right or the left edge. So I usually go over it a few times to figure out where it thinks it is. And then once I get a hole and I've confirmed that I hit a stud, then I measure over 24 inches or 2 feet, and I mark that spot. I see if the stud finder finds it, and it did. Mark another spot, drill another hole, and if that hits and there's nothing in between, then you're good. Your wall could have 16-inch on center spacing, depending on your construction, but usually with a non-load bearing wall, an interior wall like this, 24 inches on center is how you do it, okay? So now, once we've marked out the positions of the stud, we're gonna use a self-leveling laser. So this is just a little laser that I got on Amazon. It's made by a company called Huapar. And it's actually cheaper and a lot better than a lot of the other name brand options. And so we just get this and we are gonna mark it, the vertical aspect of it, directly on where that stud is. And that allows us to punch in at the top, because this module is, we're gonna be mounting these at about 96 inches tall. And then we are going to use a final piece, which is a little torpedo level here. So this is gonna mark out where the screw is gonna go in, and then the torpedo level will help us to get level like this. And then we're gonna mount this frame piece in and leave enough space on top that the 2x4 is gonna sit, and then that's where the very top edge of the module is. So we're not gonna see this from the front. The only way you can see this is from the side. So it's minimal impact. Okay, that's our game plan, let's get to it. So just before we put this module up, I wanted to show you a couple little finishings that we do. So we just put furniture pads on the bottom. It's just a nice little touch. It keeps the white fabric off the ground, and if you ever need to move them, it keeps the fabric from skidding along the floor. Okay, so that's the bottom. Let's go take a look at the top. So along the top, I'm gonna use these zip ties to be able to attach to the framing and air gapping system. And I've just sunk in these same screws we've been using for everything into the top of the module. I pre-drilled them, and I just have the smooth part of the screw shank exposed, and the zip tie is gonna go around like that. Because there's so much pressure on the zip tie, it's not gonna be able to slip off the top because the screw head flares out. And I've just made sure to sink it in far enough that none of the threads are exposed, because they could shred the zip tie. Not likely, but I just think about safety all the way through. so here's the mounting system. We've been able to hit 2 studs with our screws, but because this is exactly 4 feet long, we're never going to be able to hit 3 studs with a 24-inch on-center stud spacing. So what I did on the third one in each scenario is I actually drilled into the wall and I used a drywall anchor and then came through with a construction screw. So we have 3 mounting points on each. We went up with screws here to mount the blocking piece, and you can see there's a screw that's exposed there, and on the other side of that it's going to loop in with the zip tie. And that's how it all goes together. Let's go ahead and put this panel in. Okay, so here we are with the rear wall modules in. You're gonna hear the word modules a lot from here on in. Modules, modules, modules. These are the modules on the back wall. And I wanted you to hear the difference between the bare room and how my voice sounded there and how it sounds just with this incremental step forwards. So we'll cut to my voice before, but let's just listen to how loud and live the starting space sounds. Here we are with the rear wall modules. We'll cut back to my voice. Yep, sounds like a bare room to me. And then here we are in the room with the rear wall modules in place. Cool. Next step in the build is going to be putting in the sidewall modules. And they're there to just generally damp the room, but they're also going to do something else critical, which is address the flutter echo that happens in any room that has parallel surfaces that are reflective. Okay, so the easiest way to hear flutter echo is it's a very short echo that ends up taking on a tonality, a pitch to it, and that corresponds to the distance between those 2 boundaries. Many of you will be familiar with it, but in case, I'm just going to clap so you can really hear with the exposed walls what that sounds like. So you can't really necessarily hear distinct echoes, but you're hearing them filter into a pitch, basically creating a sustained frequency that you can hear. So the sidewall treatment is going to take care of that. And that's our next step. Yeah. So just to wrap up on this, though, I also want to show you this white fabric. Thomas is really happy with it. I'm happy with it. It makes a small room just feel more open. But I also want to emphasize the importance of wrapping with a first layer of that cotton batting, because anytime you're using a light fabric, it has a bit of translucence to it. You can kind of see through it, and especially you can start to see framing. Now in this case, you can see a tiny bit of the stud and the blocking pieces, but it's largely just kind of smeared over. And that first layer of cotton batting, don't skimp on that stuff. Wrap your modules. It does all kinds of stuff in terms of durability at the stress points, but also it's, I think, really critical with this light colored fabric.
I wanted to comment quickly on acoustic testing and the different types of tests that I do all throughout the build process. So you saw in previous episodes in the series, I went through my full acoustic testing process and speaker positioning and microphone positioning and all of the best practices. If you didn't see that video, we will drop a link to that and my acoustic testing best practices PDF below. But every phase of the build, every time we change anything, I always run a full battery of acoustic tests. And I want to be able to see every step along the way, the incremental progress that each module made. Partially that's for my own learning as someone who's designing acoustic modules and installing them in studios. And then also it's just nice for the client to be able to see the incremental improvement that each phase of the build is doing. So yeah, each step, whenever we install a module, we do a round of acoustic tests, and I would suggest that you do the same. Coming up soon in the series, if you stay tuned, I will go through each one of the incremental tests showing the difference that each type of module created in the studio. So stay tuned for that.
All right, so we're gonna position Thomas directly over the listening position, and then I'm gonna have him help me using the mirror to mirror test where the primary reflection points are on the sidewalls. And there will be 2 of them because the left and the right speaker are gonna hit the wall in different places. Okay, so Thomas, you look like you're good. Your ears are aligned maybe an inch forwards. There you go. Yeah, ears are aligned over the LP1. And yeah, so I'm gonna set the mirror at a height approximately equal to the acoustic axis of the speaker, like that. And then Thomas, you can look over here at the mirror. I'm gonna hold it as flat to the wall as I can, like so. And then you let me know when I'm dragging it across when you can see a speaker. And you're seeing the cabinet edge, right? In this case, that guy right there? Yeah, awesome.
You can probably go back a little bit.
Okay.
Okay, split the difference. Right there.
Yeah, nice.
So this area right here, we are gonna wanna have covered with our sidewall panel. So I'm gonna make sure the front edge of it comes right here, and we're good to go.
The process for building the sidewall modules is pretty similar to building the rear wall modules, but with two important differences. First, because the ceiling in Thomas's room slopes down towards the front of the room, we are going to reduce the height of the modules. You may think, oh, you could angle the top of the module, and you certainly could, but that's just a lot more fussy angles and construction work and cutting of rock wool than I wanted to do. So we just dropped the entire height of the module so that it was going to sit inside of the ceiling dimension, the ceiling height at that point. The other more important difference is that energy is going to be traveling through the side of this module from the front to the back of the room. And because these are placed on the side walls, we need to account for that. And I'm going to vent the studs that comprise the side of the modules. And this is going to allow energy to be able to move into the module laterally and to pass out the back of it. And it just prevents the studs, which are reflective because they're made of wood, from creating a reflective surface that would reflect energy back to the mix position in the front of the room. Once you have the first stud cut for your module, it's a great idea to bring it into the room and to do a test fit, just to make sure that you've measured correctly. So what I do is I bring one of the studs as well as two offcuts that will simulate the thickness of the top and bottom plate, because that needs to be accounted for in the total height of the module. I bring them into the room, I stack them on top of each other, and I just make sure that I've got enough space for clearance at the top of the ceiling. I always want to make sure that I can reach up, around, and behind the module to be able to access the air gapping system and the zip ties if I need to, so I never make my modules all the way up to the ceiling height. This is more important with a flat ceiling where you don't have the angle like Thomas's does, but I always leave, I would say, maybe 3 to 4 inches of a gap, just enough to be able to fit my hand up, over, and behind the module. All right, so we've got our first sidewall module built, and now we're gonna do something that is a total best practice, which is venting it, okay? So because energy is gonna be hitting this from the side, the frames, it can create a reflection back into the front of the room, which is undesirable. So we're going to take a chunk of the wood out, otherwise known as slotting or venting it, so that energy can pass through the acoustic treatment laterally as well as striking it from the front, okay? And the reason why we don't do this on the back wall modules is because all the sound is coming towards them pretty much directly, but on the sidewall modules, we want sound to be able to pass through the acoustic treatment on the way to the back of the room. So because this frame is not load bearing, again, we're using 1x lumber and we can take some of it out. We don't want to remove too much that it's going to be structurally weak and crack when we pick it up and move it, but we can definitely take a bunch of this out. Okay, so I'm going to use my setup blocks here. This orientation is 2 inches. So I'm going to mark in this 2 inches from the top plate. It's going to give us lots of leeway room like that. And I'm going to go to where the blocking piece is, where the screws are. We don't want to get anywhere near those screws with our jigsaw. And we're going to mark that out too. And then on the side, if I flip this setup block up on its side, this dimension is 1 inch. I'm going to add a 1/2 inch to that using second setup block. I'm going to mark that. I'm going to mark this. And then do the same thing on either side. Get down here. And then I'm just going to use one of these boards as a straight edge, right? I'm going to draw that really roughly like this. And these are going to be our kind of margin lines for the vent, okay? So now I'm just gonna do the same thing, rinse and repeat. Okay, now we are ready to punch through with our spade bit. So I start on one end, right up close to the end, like so.
punch through like that. And I can feel that it's pierced on the other sides. There we go. Okay. Then we get our jigsaw. So this is what gives the jigsaw the ability to get in there. And with the jigsaw, make sure that the blade is not touching anything before you get it going. All right, so once we've got these vents cut with the jigsaw is a little rough, right? It leaves tear out, and also it's tough to get fully into the corners. So this is optional, but I like to do some extra finishing work on these guys. So I use routers. So this is my little Ryobi palm router, and I've got a straight cut bit on here. So you have to use this one carefully by hand. And I just use that to go in and clean up any areas like this in here where the jigsaw just didn't get in there. And then I have another router. This is my corded Bosch router. And I have a roundover bit on there. So if you want the cheap solution, you can just sand the corners of the vents with 80 grit sandpaper, but that's pretty time consuming, and you can also get splinters in your hands and stuff like that if you're not careful. So I love the roundover bit approach because you can just buzz these guys really quickly, and it's just gonna create a nice smooth rounded over edge on your vent. All right, so I just want to pause for a sec and talk about the design of these sidewall modules with respect to the blocking pieces. Any module that you have that's shorter than 8 feet tall is going to have the Rockwool batts cut. And this is one design. So what we did is we measured into the midway point and we put in these blocking pieces. And there's two unfortunate aspects to that design, and there's a better way to do it, which I want to show you. So the downside is that all 4 of these batts are shorter than 4 feet, and it means all 4 of them need to get cut. The other aspect of it is that because these blocking pieces meet exactly in the middle, there's an access problem where we had to toenail in screws from the side. Now here is the alternative design. So, and this is the one that I recommend. So what we did here is this stud bay is measured out to 4 feet. This is the short one, so only that one needs to get cut. And then I offset them so that this stud bay is the longer one, and this doesn't need to get cut. And this is the short one that does. So only 2 batts need to get cut versus 4. And because we've offset the blocking pieces, you can access to screw here, you can access to screw here, nothing gets toenailed in, and pretty much for all intents and purposes, this is the better design. I just wanted to show you the 2 alternatives.
A quick note about handling and installing insulation in the modules. It doesn't matter if you're using Rockwool or fiberglass. In either case, you're going to want to wear some personal protective equipment. You are definitely going to want to use gloves, wear long sleeves and long pants to prevent fibers from getting in contact with your skin, wear safety glasses, and also a mask. It's a little less of a concern when you're working outside rather than in a confined space, but regardless of the situation, I like to mask up when I'm handling this stuff. And a note about safety, there's a lot of people who have read some stuff online saying that Rockwool is a toxic product or that fiberglass is a toxic product, and that it has been pretty much disproven. All you have to do is take a look at Rod Gervais' book, Home Recording Studio, and he has cited the actual science behind things. It's completely safe to handle if you handle it using the proper guidance from the material safety data sheet. The final thing I'll say is that when you're cutting Rockwool, you're going to get some fibers that are going to float down to your floor. And to make sure that you don't kick them up into the air, never use a broom and a dustpan to sweep those up. Always use a vacuum. So that just makes sure that it sucks any fibers off the floor without disturbing them and kicking them up into the air like a broom would. If you follow those rules, you're going to be good. For cutting Rockwool, you can use a bread knife. Something serrated is going to be really helpful. I have a specialized insulation knife, but to be honest, a bread knife is just as good. And it also is very helpful to have a thin, flat blade like that when installing Rockwool into the bays, because a lot of times it will compress a little bit further than flush with the front of the module, or it'll be sticking out proud of the module. Either way, it can be really helpful rather than using your hands just to slide a thin metal edge down the side to be able to get the Rockwool right nice and flush with the front of the panel. Cutting light density fiberglass is a different story entirely. I don't use the insulation knife or bread knife. In that case, a lot of times I press it down and then I use a really long extended utility knife, like an X-Acto knife, and the really sharp edge will help to cut through. A lot of times I'll use a piece of lumber that I can press down to make a straight edge to run the knife along the edge of, and that both compresses the Rockwool to make a nice cut through and provides me with kind of a fence to run the knife down. The installation, mounting, and air gapping process for the sidewall modules is very similar to the rear wall modules. We're just using a narrower air gap in these ones. All right, so we are gonna start building the front corner traps now, front corner modules, and that is gonna require us to rip some stock on the table saw. So I wanna talk about the table saw. I think I just have a couple best practices in terms of setting it up. So we're gonna be working with this 1x6. And the porous insulation we're going to be filling it with is the 2-inch cavity rock. So we're going to want to rip these through the table saw. By the way, this is a cut, and if you're going lengthways, this is a rip. Okay, so just some basic terminology. And yeah, so the first thing we're going to do is we're going to set up the width of the fence here. Now, what a lot of people do when they're setting this up is there's a ruler on here and they say, okay, 2 inches, we're gonna do this, we're gonna snap it on. The problem is that this may be a little bit off, and also the fence can be out of square. So there's two quick best practices that I do. One of them is I use my speed square, and I use that to square the fence. The next thing I do is I use our trusty setup block, and this way is exactly 2 inches, and I literally just place it between the fence and the blade. I bring it against the blade, don't push on the blade, and I make sure that one of the tooth edges is in contact with the setup block, and I just push it like that, make sure it's square, lock it off, boom, take the setup block out, you're good to go. Okay, the next thing I do is when you're doing a long rip, you want to have some lateral pressure into the piece so it doesn't wander and create a jagged edge. And so I use this aftermarket add-on, which is a feather board, and it just puts itself into one of the miter slots here. And then I just take a test piece like this, you just gently press it, get it lined up, snug it down, and boom, and now anything going through the table saw is going to be pressed nicely against the fence, and you're going to get a really nice, really clean rip. And then the final thing is blade depth, and you want to make sure that the blade is not coming way up over top your workpiece. I have it set so that it comes and the teeth of the blade are coming up just a little bit above where the workpiece is. And then the final thing is never use your fingers in here. You're gonna use one of these bad boys, which is a push stick, and you're gonna use that to push through so that your fingers are never anywhere near the rotating blade. Okay, and then because we're working with long pieces here, these are 8-foot pieces, to rip them all the way through, I'm not gonna do this on my own. I'm gonna have Thomas catch for me. So he's gonna be on the other side of the table saw, making sure that the ass end of the workpiece doesn't tilt and come off the blade, and he's just gonna catch it for me as it goes through, and that's the best practices in terms of using a table saw. All right, let's get cutting. The framing design for the front corner modules is very similar to the processes that you've seen us using so far. We've just made them 2 inches thick to match the thickness of the Rockwool cavity rock bats, and then we've made them a little bit shorter, again, because that's accounting for the slope down of the roof towards the front of the room. When you're cutting all of this cotton batting and fabric, I can't emphasize enough the importance of using a really good, sharp pair of scissors. There's special fabric scissors that are designed for cutting fabric. They don't need to be expensive, they just need to be really sharp and well held together. I found this great pair of Milwaukee scissors at Home Depot. They weren't that expensive, and they make cutting fabric a total dream. When you're building a studio, you spend so much time cutting, and you're also trying to get a really nice clean edge so that it looks good. And the scissors that you're using are gonna give you a professional result if you're using nice ones. Now, for mounting the front corner modules, this was actually a pretty easy process. In terms of how they're positioned in the corners, we didn't have the space to put them at an exact 45, so we angled them more at a 30-degree angle. That's what we had room for. And then at the top of the corner, you can see there's those nice pine solid wood trim pieces. So I was able to mount eye hooks in both the module and in the trim pieces using a zip tie between them to secure it in place. So here's a little reveal of the room and where we're at so far with all of the floor-to-ceiling modules mounted and installed and in place. A little spoiler alert on the acoustic testing, it's looking good, and the room is sounding much more controlled so far. More on that to come soon. Coming up in the next episode, I'm going to show you the full build process for the ceiling cloud. The cloud for this room is definitely a focal point, and it features an exposed pine frame with individually wrapped 2-foot by 4-foot modules, and a special stepped-out design with lots of angular beveled edges. Stay tuned, and I'll see you in the next episode.